And this is a sample file I gave you. And as you can see, I actually just started to go through and try to just sort of move some things around to clean it up, make it a little more orderly. But for those of you, I mean, I know Carlos, you used Grasshopper in 367 not too long ago. Yeah, I think you're new to this. But essentially what you're seeing is a lot of widgets on the screen, sort of a mind map, you know, a big bowl of spaghetti. It's called visual programming. What you're basically doing is scripting, but without the scripting language. So this is a visual way of doing that. Each of these modules or widgets on the screen correspond to like a tool that you would see in Rhino, right? So there's a tool to like create a box, like a solid, right? There's a tool to create a line. There's a tool to create a plane. And just like if you clicked on one of these tools in Rhino, in the command line, it asks you for like the ingredient, like for a line. Give me the start point, give me the end point, right? Here, like let's say to make a line, it'll have the ingredients here. And once we have the ingredients, we plug them in from the left. And then it outputs the line or whatever we're making on the right. And then we can use that and plug it into the next thing, okay? And so a lot of the stuff that you've traditionally just done manually when you're modeling something, here you're actually recording the process itself, the algorithm. And you can actually start to build in variables. So you can start to say, not can you only just rotate something, but you can say, okay, I'm going to build in a variable for how much rotation, let's say in angles or radians, and how many times you rotate. Maybe that's a number, right? You can even make number sliders so that you can, you know, change those variables by just simply sliding the number slider. Okay. And so what you'll see is that this mind map, you read it going from left to right. So the very first ingredient, the only ingredient we really need is a surface. So like I said, this is going to take a surface and it's going to break it down based off of some parameters into a series of points. And then later on, as we move from left to right, each of those points are going to get populated with boxes at the end here. And those boxes are going to be a particular size that we can govern here in Grasshopper. All right. Okay. So I'm going to just very quickly, let's see if my mouse is working. Oh yeah, okay, good. There's nothing worse than trying to model in Rhino without a mouse. It's terrible. I wouldn't wish that on my worst enemy. But I'm just gonna make something obviously not planar. So I'll draw a curve here in space. If you can see my screen in Rhino. I'm just gonna zoom out a bit here. In side view, I'll go ahead and constrain to ortho, and I'll just make a copy of this up here. Okay. And here, last, I'm just going to turn the grid off. This grid is really overly dense. It's kind of hard to see around it. I'm just going to turn my axes and grid off. I'm just going to take this other curve, and I'm just going to just manipulate some points. I'm just going to change the geometry of it a bit. There. Okay. Excellent. I have two curves. I'm just going to loft them into a surface really quickly. That'll give me a surface. And I'm just going to go ahead and turn that to shaded so I can sort of see better what that looks like. Yeah, that's good enough. This is kind of throwaway. Again, once I know how this graph works, I can use just about any surface and see what comes out. So I'll go ahead and say, okay. It's kind of a dumb surface, but yeah, whatever. I'm gonna go ahead and expand my perspective viewport, move this over so we can just sort of see what's going on in real time as we go through the steps here. Okay. I'm going to go all the way to the left. Again, this is our starting ingredient. We need a surface, and then the graph does all the rest for us. So I'm going to go ahead and right-click on the surface widget and say set one surface. When I do that, Grasshopper actually disappears and lets me start to select and reference Rhino native geometry back into Grasshopper so we can do things with it later on. So here I'm going to go ahead and reference that surface in, and now you can see it started to populate with Masonry blocks, let's say, that are 8 by 8. Of course, we have some problems going on here. We either need to have our masons get out the chop saw, or we need to start to adjust some parameters in order to create these or prevent these collisions, right, in between each unit. What's interesting is that this might actually become a common problem, in which case we might need to figure out a way to create a collision test. So it'll actually pop out and show us where we have collisions and then actually have to adjust some things. So anyway, I can adjust the course height, right? So I can say just how many of these things there are and the spacing in between. I can also adjust the center to center spacing. So that's one way we can begin to adjust for this. Of course, I've also adjusted the amount of angle, right? So I think by default, what this does is this deploys the blocks in the normal direction. So it sort of follows the flow of the surface geometry itself. So you can see each one, the sort of orientation of the masonry, each unit changes as it moves around radii, right? And so we can actually change its deviation globally. It doesn't do this individually, right? Let's see here. Center to center spacing looks a little, maybe we want to get that a little closer to 4, unless we really want some very prominent vertical mortar joints. All right. I'm just going to turn this back closer to 0. Okay, and then last but not least, this is where the actual blocks are created. And at the end, maybe we can actually add some sliders to X, Y, and Z so we can actually change the dimensions of the masonry if we wanted to. Okay. All right, but first and foremost, I'm just going to go ahead and start going through each one. I'm just going to turn the preview off, and we're just going to build this step by step visually. Let's just talk about what happens at each step, right? I'm just going to, let's see here, turn some of these previews off. Okay, so first and foremost, you'll see a red surface. It corresponds to the surface in Rhino that we brought in earlier, right? When I select a widget, the widget highlights green, but also the geometry in Rhino that's created by that widget also highlights green, okay? So this is the widget that references that surface from Rhino. And all right, so eventually, one of the things we're going to do is actually create a set of planes, horizontal planes, and actually slice the surface up like we contour it, okay? So the way I did it here, and I'm not sure why I didn't just use a contour tool. I don't know, maybe if the contour tool just doesn't build into Grasshopper preset, but I did this manually. So I'm doing a little bit of gymnastics here. First, what I do is I find the bounding box, sort of minimum size box that contains the entire geometry, right? There's just a widget here. It's finding the binding box for any piece of geometry. And so what it does is it says, okay, I'm going to find a binding box, but give me a piece of geometry. And so I plug in my surface into the geometry to contain, right? And it finds this sort of minimum box to contain that geometry. And the reason I'm doing that is because I want to see how tall this thing is. I want to sort of understand where it is vertically, right? And so I'm going to find its Z dimension. I'm going to use that. And I'm going to create a plane at the 0, 0, 0 point. I'm going to create a vertical line projecting upwards from that plane, right? And its length is going to be this Z dimension, right? So I'm going to basically draw a line that's exactly as tall as the surface that I referenced in. Okay. I don't know if you can see. I'll go ahead and just turn the preview off. Can you see? It's maybe hard to see when it's a shared screen, but see this plane and then projecting upwards. So I'm drawing a line from starting with this plane. The direction is the Z axis. And then the length I've plugged in from the box Z coordinate, right? So the Z dimension. And then all I do is I'm going to divide this curve multiple times with a distance, right? So divide this curve at every 9.416 distance, right? In other words, this distance is a variable controlled by this number slider. Okay, so go ahead and turn the preview on. You can see now, right? I've populated this line with points at every, let's say in this case, I slid the slider back down to 8. So at every 8 units, this line is divided up with a point. Okay. So we get a set of points at the end. Each of those points then gets populated with an XY plane. Okay. Now, if you think about planes in most CAD programs, the planes, they sort of extend infinitely in all directions. So what we can do is we can actually find where each of these horizontal planes actually intersects our surface, right? So we can do a BREP plane intersection tool. BREP is just a fancy word for a polysurface or a surface. Okay. I'll go ahead and turn that preview on. So now you can see actually, right, we get a set of curves where each of these planes intersects the surface, right? And I can change that by changing the spacing, right, of how many times we divide this original vertical line and populate with planes, right? Okay, so those are slicing planes. Then we get the slices, which are curves. And that's really going to set, like, you know, each of these becomes a sort of path, right, for a course of masonry, right? Okay, now, interestingly, well, I don't know, I think it's interesting. It's pretty debatable though. I'm going to go ahead and turn the previews off for all these things I turned on really quickly. And again, I'm recording this, so if you need to go back through it later on, you can on YouTube. I'm pretty good about once everything's processed, and I can upload it to YouTube pretty quickly and then embed it back into Canvas for you guys. So, but I am just going to quickly add something here. I'm going to show you what this widget does. Okay, so this is called the dispatch widget. I'm just going to plug in both the A outputs and the B outputs into their own sort of separate widgets here. Turn those widgets off for a minute. You don't have to do this. I'm just going to show you. So we have these, all these curves, right? We've basically sliced and diced and contoured this surface, right? In this case, the spacing is governed by this course height number slider. But what I want to do is eventually, you know, let's say I want to do a typical bond, right? What I need to do is select every other course and then begin to stagger it, right? In order to have the sort of typical masonry bond that you're used to seeing, right? And so what this does is this is called dispatch. It takes a list of these curves, right? These curves here, okay? You plug them in, and then you give it a pattern. In this case, my pattern, I don't know if you can see this, but I have my cursor over the pattern. It says true, false, okay? So my pattern is true, false. So what it's gonna do is it's gonna go through this list, and it's gonna go to the first item, true, the second item, false, and it's just gonna keep repeating. The third item, true, fourth item, false, true, false, true, false, true, false. And all the trues are gonna go into the A output, and all the falses are gonna go into the B output, okay? So essentially I'm making, sorry, let me just turn the preview off. Sorry, use my mouse, right? I'm getting just every other, as you can see in the green here, every other course put on their own separate list, right? So now let's say with this list, right, these curves, I can then stagger over the points. And this is how we're going to do this, right? So now that we have the courses sort of broken out into individual every other sort of lists, right? We're going to do the same thing now for each of these, but with the lateral sort of points that we're going to generate, right? So in other words, we're going to use the same sort of dispatch pattern later on. I think you'll see what happens here. So I'm just going to go ahead and delete these. Okay, delete those. So now what I'm going to do is I'm going to feed these. So let's just take a look at this one sort of set of courses. I'm going to divide them up again by a distance. I have a distance over here. Each of those divisions then are going to be a set of points. Let me just turn that on. All right. So you can see each of those curves that I've generated here, right, and the A output are divided up a certain number of times. It's not really a number of times I'm giving it. It's basically the distance as it goes from the start point all the way to the end point. Each time you travel 4.818 in distance along that curve, it populates, it divides the curve with a point, and then moves on to the next 4.818 distance, another point, etc. Okay, so we get a set of points. All right. Now also, right, we're going to take these points and we're going to dispatch them, which is pretty interesting. And this is how we're going to start to create this sort of stagger, right, between the different courses, right, for a typical common bond. All right, so let's see here. I'm just going to quickly show you that, right? So you can see what highlights in green. Once we use the dispatch, it's every other, okay? I'm going to take each of these points. I'm going to populate them with a plane. In this case, an XY plane, a horizontal plane. Interestingly, I'm also, once I take these planes, I populate these planes, and they're all like, how do I say this? They're kind of dumb, right? And then you can see that they're all in orientation of the XYZ Cartesian space, and they have no relationship other than their location to the surface, right? So the surface and the curves and the points, for instance, each of these points along this curve, right? We can look at the properties of the curve and determine its tangency and normal, right? And so that's what I'm doing here. I'm just basically taking some of the addresses along the curve. I'm plugging them in to find the tangents. And what I'm doing here is just re-rotating each of those XY planes so that they actually follow the flow of the curve and actually are reoriented along the tangents of the curve at each of their location, their unique locations. Okay. So that's all I'm doing there. It's kind of a weird thing. Okay. Then further, right, the way I get that kind of crazy rotation at the end, right, remember this slider here, is then I can start to rotate these in a controlled way, right, by using just a simple rotation widget. Now, what's nice about this is each time I'm just plugging in a list, a big dumb list of stuff. And so, you know, Grasshopper will sort of loop through and do them all for me, right? So this is also avoiding a bunch of redundant modeling and drawing and drafting on our part, okay? So for each plane that I'm plugging in here, it's going to rotate them a certain number of degrees. And then last but not least, it's going to look at this plane. It's going to say, okay, the x-axis of this plane, the y-axis of this plane, and the z-axis of this plane, I can go ahead and populate with a box going from -4 to 4 in the x, -4 to 4 in the y, and 0 to 8 in the z, right? And so it's going to actually create a set of boxes there. All right. Now, going all the way back, we're going to do the exact same thing, but with the falses, right? So the other sort of courses, right? But the other courses, you'll see that we have, again, a set of points every 4.818 units. In this case, we're going to run the same dispatch, but instead of using the A output, we're going to use the B output and populate those with planes, and then straighten out those planes, right? And then populate those with boxes as well, right? And so that's how we sort of get the stagger, right? For, let's say, a typical common bond. So thinking about this just for a moment, right? We have course height. We have the center to center spacing moving laterally across each course. We have a sort of angle of orientation. Really all we're kind of missing here is this sort of how do you say, the dimensions of each unit. So let's go ahead and do that, right? These want a domain, the sort of minimum maximum. So we're going from -4 to 4, -4 to 4, 0 to 8. So there's a little bit of stuff to do here. One of the things I'm going to do is actually find where those domains are in the math widget, or I'm sorry, in the math tab. I'm going to figure out a way to construct a domain here. Come on, there we are. And that way I can plug this domain into X. I think by default it's set to 0 to 1, so it's going to be a really tiny unit here until we build in some variables. So we'll make an X. I'll go ahead and copy and paste this in. Another one, we'll make that a Y. We'll make this a Z. Now, I don't know why you would make a totally custom Masonry unit here, but why not? Let's just try it for fun. Now, one of the things you'll notice is that we've basically defined sort of center points for X and Y. And so what I'm going to do is I'm going to create a number slider. I'm going to double click on that and set a new minimum maximum for the slider. I'll go up to, like, let's say 16 inches. And I'm going to go ahead and let me think about this for just a moment. I'm going to make this a little bigger. One of the things I'm going to do here, right, is it's asking for, let's say, the minimum to the maximum. And before we use like a -4 to a 4, right? So I think what I'm going to do is I'm going to take whatever this number is as a sort of legit actual dimension I want. So I'm going to go ahead and divide it by 2. So I'll go ahead and use the division widget here. We can do simple arithmetic like that. Plug that in, divide by 2. Again, if you're lost, don't worry. I just want you to see if you, like, conceptually, does this stuff make sense, right? You don't have to know where all these tools are. You'll get there. Don't worry about that. Okay. So we're going to divide that by, so we're going to divide this always by 2, and we're going to get something out here. Let's see, the result of division 3.95. Okay, perfect. And so I'm going to plug this in for the beginning and the end. For the beginning, I want to take the negative version of this. So I'm going to say expression. I'm going to say take whatever -1 times, I'll use the asterisk, and then X. So whatever is plugged in as X, we'll multiply -1 against it, right? Now we'll get a minimum like that. All right. Now I'm going to do the same thing. I'm just going to copy and paste this so I don't have to go through the motions again here. We'll use that for Y. I got to do the same thing here, build an expression. Say always multiply the input by -1, so we get the negative version of that. Yeah, just a negative guy, I guess. All right, that's weird. There we go. That's a little better. And man, that Z, wow, that Z is kind of weird. Here we go. I'm just going to plug this in for the max. And that way we always have a bottom and a top established. Yeah. All right, so now we can even go further and customize the units. Let's say, I don't know why you would do this necessarily, but let's say I'm going to go to 4 inches here. But over here, I'm going to say 16, 8 by 16 units. Let me just click and quite literally change this to 8 and 4 and 8. There we are. Sorry, my thing is like beeping at me. I'm not sure why. Let's see here. Right. So we could begin to really change some things around here if we felt inclined to do so here. Let me go ahead and hide this surface. Just get out of the way for a moment. Let's see what we have here. So why is my spacing so goofy? How strange. Oh, because I'm always doing half. Sorry, so 8, yeah. I'm a moron. All right, here we go. Let's go the other direction. Right, so that would be pretty strange. And we'd have to do all kinds of stuff to actually make that work, wouldn't we? But nevertheless, let's see. It still seems off to me for some reason. Not sure why the coursing is off, but anyway, that's that. That's if you wanted to, like, let's say, build in the sort of last set of variables. All right, I'll go ahead and delete that, and then I think it just defaults back to what it was before. Yeah, -4 to 4. Yeah, cool. Okay,